Hey everybody, it's Mr. Swank with another Chemistry 1 lesson for you. And today's going to be a little bit easier, I think. It's Wednesday, May 13th, so let's start with a joke. You know, my wife hates it when I take kitchen items that she needs and I hide them. But that's a risk I'm willing to take. Let's move on. Our objective today is we're going to calculate molar mass. Now, you might be looking at that going, I don't know what molar mass is. Is that the mass of a tooth? Because molars are teeth. I'm funny all the time. No, molar mass, of course, goes back to the idea of a mole, which is what we've been talking about. Now, the previous days, we've been talking about the idea that 1 mole is equal to 6.02 times 10 to the 23rd particles. But we're going to move on to something a little different today, okay? We're going to talk about mass and the mole. And the idea is the mole is also related to mass. And the mass of 1 mole of any substance is called its molar mass. Okay, so why do we need that? Well, think about it. I've been talking about getting the mass of different things, like, say, a paintbrush, or not getting the mass, but getting how many moles or particles are in it. Okay, so how would you figure out how many particles are in this? Well, we said about using moles, but if a mole is 6.02 times 10 to the 23rd particles, I need to know the number of particles. I can't count how many particles are in this. That's impossible. So how do you figure out how many moles are in something without having to count the particles? Well, we use what's called the molar mass. There's 2 ways to calculate molar mass, and it depends on if something is an element or a compound. Elements are really simple. For an element, its molar mass is equal to the atomic mass of the element from the periodic table in grams. Okay, so you need a periodic table. Do you have one? Well, I'm assuming if you're watching this video, you're on the internet, so you could Google one. Or go on the Google Classroom, because you know what? I uploaded your periodic table onto there. It's under materials, okay? So if you need it, take a moment, pause the video, and bring it up, because you're going to need it. Do you have it? All right. So for example, what is the mass of 1 mole of carbon? So what you're going to do is go find carbon on the periodic table. Did you find it? Carbon C. What's the atomic mass there? It should say 12.01. The mass of 1 mole of that, then, is 12.01 grams. You take the atomic mass and you put grams after it. That's it. Easy, isn't it? Okay. So for another example, look at lithium. What would be the mass of 1 mole of lithium? Well, lithium's atomic mass is 6.94. Put grams after it. There's the mass of 1 mole of it. It gets a little more complicated with compounds, but it's still the same basic idea. You're still just going to use your periodic table, but there's a little bit more math involved, because 1 mole is equal to the collective atomic mass of all present elements from the periodic table in grams. What does that mean? You're going to find every piece of the compound, get its atomic mass, add it all up. That's going to be the mass of 1 mole of that substance. So let's take a look at water. What is the mass of 1 mole of water? Well, first things first, we need the formula, H2O. Okay, it's 2 H's and 1 O. Now, it's important because while water is made of hydrogen and oxygen, you're not just going to take the atomic mass of hydrogen and oxygen and add together. You need to account for how many of each piece there is. For example, hydrogen has an atomic mass of 1.01, but there's 2 hydrogens. So we take that mass, multiply it by 2. That's 2.02 grams from hydrogen. Next, we do oxygen. Oxygen is 16.00 on the periodic table, times 1, because there's 1 oxygen there, equals 16.00 grams. Good? Now, once we get that, we can add it all together because it's the collective atomic mass. 2.02 plus 16 gives us 18.02 grams in 1 mole. Okay? It's all about just finding the atomic mass of each element, multiplying by how many of each one there is, and adding everything together, okay? Let's take a look at another one. What is the molar mass of iron 2 nitrate? Now, I gave you the formula. Now, this looks really complicated, but I promise you it's not going to be too bad. So we're going to break it down. First, let's look at iron. Iron has a mass of 55.85 on the periodic table. Now, we're going to multiply that by the number of irons there. Is there a number next to iron? No, so how many do we have? 1. 55.85 times 1 gives us 55.85 grams. No problem. Let's move on to our next element. Nitrogen. Nitrogen on the periodic table is 14.01. That's the atomic mass. Times how many? Well, if we look at nitrogen here, there's no number next to it, so you might automatically think 1, but be careful. Because nitrogen is a part of nitrate, and it's in parentheses with a 2 outside of it, right? Just like in math, that 2 is going to distribute to everything in there. So 1 nitrogen times 2 is how many? 2. 14.01 times 2 is 28.02. That's nitrogen. Our last one is oxygen. Now we know from before, oxygen is 16.00 times how many are there? Well, there's a 3 next to it, but then there's a 2 outside the parentheses. So how are we going to do that? Just like in math. Take the number outside the parentheses, multiply it by what's in there. 2 times 3 is 6. 16.00 times 6 is 96.00 grams. So now we have all our numbers. So what are we going to do? Add them all together. 55.85 plus 28.02 plus 96.00 gives us 179.87 grams per mole. And that's our answer. Again, guys, if you want to review the video, go back, check it out again. But it's all about just finding your atomic masses, multiplying by the number of atoms, and then adding up all your totals there, okay? That's how you get the molar mass of anything. There is an assignment posted where you're going to have to calculate a bunch of molar masses. Give it a shot. If you have any questions, don't forget to comment, email me, whatever. But good luck, everyone. We're going to move on tomorrow with some other stuff. And, hey, have a great day.